Good evening, Irish Algebra. This is your review lesson for December 12th. Your test is tomorrow. It's a Chapter 6 test. I'm expecting you to do really well on it. You guys have been working hard. I know the flipped lessons have been helping out. Hold on 1 minute here. Okay, I think we're all right now. Having a little technical difficulty, but that's all right. It seems like that this USB cable keeps loosening itself. Hopefully it'll stay going. All right, so let's see here. Let's say how we're going to approach this. First of all, we're going to start off with absolute value. And remember, oh no, not absolute value, absolute value. Remember that the definition of absolute value is the distance from 0 on a number line. You need to know that definition. Okay, the distance from 0 on a number line. So that means that a lot of problems will have more than one answer. Let's look at a simple problem, something like this. 5 minus 9, we need to take the absolute value of that. Well, just like if these were parentheses, we would do what's inside first. And we would do 5 minus 9 and get negative 4. Now, we think of a number line and we ask ourselves, how many spaces from 0 is negative 4 on a number line? Oh no, let me count on my fingers and toes. Ooh, my toes haven't been washed in a while. That's kind of gross. Oh, look, 1, 2, 3, 4. 4 spaces away. That means the absolute value of negative 4 is 4. That is my answer. That is not the same type of problem as one like this. I have the absolute value of 5 minus x equals 3. Okay? This has to be treated as an OR situation. Well, I'll write down 5 minus x equals 3, or 5 minus x equals negative 3. And this second part is what I always used to mess up on. I know you guys have the advantage of having me for a teacher because I know how to teach you so that you won't make that mistake. All right, I'm going to subtract 5 on both sides here. I'll get negative x equal to negative 2. Divide by negative 1 on both sides. And I'll get x equals 2. Or, okay, over here I'll subtract 5 from both sides. I'll get negative x equals negative 8. Oh, silly me. Negative x equals negative 8 is what I meant to write, but I did say that. And then I will divide each side by negative 1 and get x equals 8. There is my solution. Okay, I can test them. Plugging 2 in, I'll get 5 minus 2 is 3. Absolute value of 3 is 3. Checks. Plug in 8. 5 minus 8 is negative 3. Absolute value negative 3, positive 3. It checks. I did them both correct. Of course, that leads me into absolute value inequalities. It doesn't want to rewrite. So let's say we have a problem like this. Absolute value of x minus 4 is greater than 3. Well, remember, this is a great OR problem. This is a great OR problem because great OR sounds kind of like greater. So x minus 4 is greater than 3, or x minus 4 is less than negative 3. All right, I'll solve over here. I'll add 4 to each side, and I'll find out that x is greater than 7. Or over here, I will add 4 to each side, and I'll come up with the inequality that x is less than 1. There is my solution. If I have a game and you win the game, one of two ways. You can win if you get a number greater than 7, or you can win if you get a number less than -1. Oh, excuse me, less than +1. So on my number line, I will show, let me just check, make sure I don't have a sign error there. Now I'm doubting myself. Nope, it is +1. I'm good. All right, so I put +1 on. It's an open circle, open point. I put +7 on. It's an open point. And I know that ors shade this way. And this way. Okay. By the way, if you ever get an unusual situation on an or where it shades this way, but then it also shades this way, that was like the one problem from the homework. That's a unique situation. That one ends up being all real numbers because it covers the whole number line because it's an or question. Those points don't act as endpoints like they do in the and problems. All right, let's look at an and problem. I can't seem to get a blank page. There we go. All right, let's try out 2x minus 5 is less than -7. Oh, danger, Will Robinson. Danger, danger, danger. On this one, we see that the absolute value has to be less than 0. We know that's not possible. This is a no solution problem. All right, I'm going to pause now because it's time for the algebra party, but I'll get back to you guys as soon as I can. Okay, hopefully you're seeing why it is so important to understand the definition of absolute value. Let's look at an inequality that will not come out to be no solution. Say something like -2x plus 4, and we'll make that less than or equal to, say, I don't know, 12. Okay, this is an and problem. How do I know? Because less than, right? Less than. That was the little cue I gave you to help you remember that. Start off -2. Oh, I'm going to do it, set it up two ways. I'm going to set it up the way Josh Perry likes to do it. And a lot of others have adapted to it. They really like it. And -2x plus 4 is greater than or equal to -12. Okay, now I'm not going to solve it that way because I'm too lazy to do it that way. I'm going to set it up my way. But if you do it Josh Perry's way, you should get the same answer. Okay, so that's how Josh would set it up, and some of your other students would do it that way. I'm going to set mine up this way, and I'm going to do, I'll just draw a line so you can tell the difference in the work. -2x plus 4 is less than or equal to 12. And then I do my inequality over here and a -12 here. They mean the same exact thing. I like my way because it seems like less work to me. I understand it, but my way is not better. You do it the way you understand it. I want you to understand what you're doing and get the correct answers. All right, so I am going to subtract 4 from all three sides, if you think about it that way. And when I do that, I'll end up with -16 less than or equal to -2x less than or equal to 8. All right. Now, I have to divide by -2. Whoop, 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 whoop. You should hear warning sirens going off. Danger, Will Robinson. I just divided by a negative in inequality problems. 8 greater than or equal to x greater than or equal to -4. Okay, if you did Josh's way, you would have gotten two statements like 8 is greater than or equal to x and x is greater than or equal to -4. When you go to graph, I will show -4. I will show 8. And let me see here. They will be closed circles. Closed circles. And I'm going to test mine by picking a point that makes this true. I need a number that 8 is greater than, but the number I pick has to also be greater than -4. I'll pick 0. So 0 would be smack in the middle here. I'm going to shade the middle region. If I pick a point outside that middle area, I'll get a false statement. It might be true for part of the inequality, but not for both. Okay, moving right along. By the way, if you're looking for extra problems, the blue section in the back of your textbook, let me see, starts on about page 753 and then goes all the way to page 755, it has some extra problems. Okay. Now, I'm not going to solve a compound inequality because right there, in both of those absolute value inequalities, I had to solve compound inequalities, so I'm not actually going to do those. All right, but what I am going to do, oh no, I lost my page. I'm going to graph some absolute value functions. Let me see here. Oh, my content is not showing up. Okay. There we go. I found a graph, and I'm going to go ahead and label these X. Oh my goodness, Mr. Lawrence. I'm going to label my axes X, Y, and the origin. And let's say I have an equation like y equals negative 3 over 2 times the absolute value of x plus 4, and we'll do plus 5. Okay. To graph a problem like this is simple. The first thing I need to do is to, one, find my vertex. Okay, my vertex. For the x-coordinate of the vertex, I'm going to look here. I'm going to take that 4, only I'm going to change its sign. So the x-coordinate of my vertex will be negative 4. Okay. For the y-coordinate of the vertex, I look here. I don't change the sign. 5. My vertex occurs at negative 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. There is my vertex. Negative 4, 5. Okay, now I see it's kind of like my slope over here, and I also see it's negative. This tells me it's going to open down. Yeah, because it's a negative. Now, to get my next point, I'll just use that slope that's sitting there. I'll go down 1, 2, 3, and then right 1, 2. But because of symmetry, I also have to go back 2. And then from each of those points, I'll count down 1, 2, 3, 1, 2. But then because of symmetry, I go down 1, 2, 3, and back 2 the other way. And there I am ready to draw my graph. So it'll look something like that and like that. And I'm running into trouble there, but that's okay. All right, there we go. There is my oh no, that moved on me, didn't it? All right, no problem. Let's do this. And let's see here. Let's go with negative 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, like that. And I think this one's okay as is, but we'll double check. 1, 2, 3, 1, 2. I like it. Okay. And then 1, 2, 3, 1, 2. There we go. Now I can get this one and make it look prettier. And there it is. All right, there's my absolute value graph. Now, I'm not going to do a whole bunch of those, but let's see if you can identify correctly the slope and the vertex. Okay, the slope is going to be 4 over 1. And of course, that will only give me half, and the points of symmetry would be like negative 4 over 1. The vertex is going to be at 0, negative 4. There's nothing being added to x, so it's like plus 0. I can't change the sign because 0 doesn't have a sign. The negative 4 gets me my y value. Okay, let's try one more. How about y is equal to the absolute value of x minus 3? Well, the slope is sitting there. It's like 1 over 1. And of course, for the point of symmetry, it'd be like negative 1 over 1. The vertex is going to be 3. I change the sign. And then it's like plus 0 out here. So 3, 0 is my vertex. Okay. But let's go back a minute and talk about domain and range. Okay. Let's go back to this one. And let's look for our domain and our range. Remember, domain are your x values. Did you hear that? Domain are the x values. I like to use a vertical line and ask myself, is there any place on the x-axis that I can put this line that will not eventually cross the v, the absolute value graph? No, because even when I'm way out here, if I extend this guy long enough, look at that, he hits, right? Okay. If I move this out here, I would need a bigger smartboard, but eventually the V would cross the blue line. So there's no positive value that X is not allowed to be. There is no negative value that X is not allowed to be. And X can also be 0. So that means my domain is all real numbers. All right. Now I need my range. My range. Okay. Well, for range, I'm testing y values. And for the y values, I like a horizontal line. Okay. I like my horizontal line. And let me see here. I like my line to be solid. All right, line style, solid. And we'll go for kind of a purplish color. All right. Now, I look here, and it looks like that y can be anything from this number on down. Right? Oh, what just happened there? Oh, that's my download on YouTube. Sorry about that. Okay, so y can be any number from here down, because when I move this horizontal line down, I cross the graph. When I move above that number, the v will never touch it. So my range is everything from this y value all the way down forever. Well, what is the y value there? It's 5. So my range is all the y's that are less than or equal to 5. And there you go. All right. Let's see here. Let me graph this one. I know I said I wasn't going to, but I will. I don't know why those are there, but let me go ahead and graph it. Yikes. Look at this. Crazy business. All right. Let me get a graph out here. All right. So I plot my vertex at 3, 0. And then my slope is like 1 over 1. Symmetry gets me these points. So my graph is going to do this. Okay. Well, my domain. Again, X can be all real numbers. My range. It looks like the Y values can be anything from this point up. I draw that horizontal line there. Hey, that's a pretty spiffy looking line there for drawing a freehand. All those Y values up there will eventually intersect with that V. Y values down here will not. So let's find out the Y coordinate there. Well, that'd be the point 3, 0, wouldn't it? That's my vertex. So the range will be all the y's that are greater than or equal to 0. Not 3. 3 is the x value. Okay, one more domain range question. This is like one we did in class today. Let's see here. Put that on. Let me get you a graph that looks like this. Okay, there's that graph there. And let me give you some coordinates here. It looks like this is going to be 4, 9. This is going to be 2, 1. 1, 2, 3, 4, 5. 1, 2, 3, 4. That'll be 5, 4. And this will be -9, -3. Okay, my domain. This one's a little bit trickier, but if you get it, it shows you totally know what's going on. I look at my vertical line, and I see I can move it everywhere from when x is -9 all the way to when x is 4, except right here at 5. -5, excuse me, that should be a -5. X can't be -5. So my domain goes all the way from -9, stops at -5, and then starts up again at 4. So my domain would be -9 less than or equal to x, which is less than 5, and 5 is less, oh, no, let's do this a more simple way, which is less than or equal to 4, but x is not equal -5. X cannot equal -5. So it includes all those x values from -9 to +4, but not 5. That is one way to represent the domain. All right, the range. To do the range, I'll need my horizontal line. I don't know if that one's as pretty as the last one, but I'll look and see I can go all the way from -3 up to +9, except there's a hole here at 4. Oh no, I made a mistake, ladies and gentlemen. Tell you what, please disregard this one. I got a little too fancy for my own good, and I've made an error because, yeah, I apologize. I just caught that mistake. Sorry about that. The range can be all the numbers from -3 up to 9 because over here there's a value and it is a closed point. So the range will be from -3 less than or equal to y, which is less than or equal to 9. The domain, a similar thing. No, the domain is not a similar thing. I did have the domain correct. Okay, sorry about that, ladies and gentlemen. I got a little too fancy and I confused myself. I shouldn't be doing that on a review video. All right, I don't think I'm going to put anything else in this video because I think you know how to do them all. All right. Okay, Mr. Lawrence signing off.